All right, this one is factoring out a constant before factoring a quadratic. Or as I like to call it, factoring out a greatest common factor. You have to look at all three terms, 4x squared minus 12x minus 72, and they're saying factoring out a constant. That means a number. So you only want to focus on the 4, the 12, and the 72 and figure out, well, what number goes into all three of those. Actually, there's two numbers that go into all three of those. Since they're all even, I know they're divisible by 2. So I could factor out a 2, but whenever you're factoring, you want to factor out the largest possible factor. And that would be 4. Because 4 goes into 4 once, 4 goes into 12 3 times, and 4 actually divides into 72 18 times. So I'm going to factor out the 4 first. So I'm going to be like, okay, 4x squared. And in my head, visually, I'm thinking, what is 4x squared divided by 4? That's what's going to go right here. And 4x squared divided by 4 is just an x squared. Then I'm going to take my minus 12x and divide it by 4. And whatever I get is going to go here. Well, negative 12x divided by 4 is a negative 3x. And then I'm going to take my minus 72 and divide it by 4. And negative 72 divided by 4 is a negative 18. That takes care of the factoring out a constant before factoring your quadratic. I still have a quadratic equation here because it's got an x squared. So I have to factor that next because it does say factor completely. But this factoring out a constant business, factoring out a constant before factoring the quadratic. So that's what the yellow is. I pulled out that 4, all right? Now I've got to finish factoring, and this is just like the, where was it? I did it a little while ago. I've lost it. Where did it go? Oh, there it is. No, that's not it either. What the heck did I do with that piece of paper? I'm losing my mind over here. Where'd the piece of paper go to? Oh, it was the one that said factoring out a univariate something or other. Anyway, I don't know what I did with it. That is so weird. Oh well. I'm just going to unfoil this. And so when I do that, I'm going to get 2 binomials that would multiply back to give me this. And just remember that your first term here, which is x squared, that comes from first times first. So I only have one choice. It's x times x. Now, on this one, my back half, or my last term, the minus 18, that comes from last times last. If you heard that, that was my cat. I don't know what his problem is. And so I need 2 factors of 18. So my choices are 1 times 18, 2 times 9, 3 times 6, 4 doesn't go into 18, 5 doesn't go into 18, but when I get to 6, I've already got 6 over on this side, so I've found all my factors. But this 18 was a negative 18, which means one of these factors had to be positive and the other one had to be negative. So I could have had a positive 1 times a negative 18, a positive 2 times a negative 9, a positive 3 times a negative 6, or the reverses of all that, a negative 1 and a positive 18, a negative 2 and a positive 9, a negative 3 and a positive 6. So there's actually 6 possible combinations I could put in here. But I need the pair that will give me a middle term of -3. And that pair would be, drum roll please. Oh, that was not a good idea. Oh shit, I'm sorry. My phone fell off. Oh my, I won't do that again. It's this one here. I can't even pause my phone. Oh, I'm a hot mess. Okay. So I'm gonna have an x plus 3 and an x minus 6. Oh my God. So if I wrote it all out in one color, I'd have 4 times an x plus 3 times an x minus 6 as my answer. That's what I'm gonna stick in this box up here. And if you foiled it back, x times x, that's the x squared. My outside is -6x. My inside is +3x. -6 and +3 adds up to -3. And then last times last, 3 times -6 would be -18. And then of course, if you distributed these, then it would take you back to this. So that's my answer and I'm sticking to it. The end.